Yeah, give it. Yeah.
Or did you want to go through your slides first? Or?
Yeah, I just kind of, since the recording, this kind of starts out with this screen, and then I'll share with you. So first of all, I'd like to thank our guest presenter tonight, Micah. He's got a really good talk on hash cracking, which he gave the first time at Pone School in Denton back last year or earlier in the year, wasn't it? Was it this year or towards the end of last year? Yeah, last November he gave the talk, and then he also gave a talk for one of the other instructors here at Richland College. And one of the students was asking about learning more about hash cracking, and I thought, I know someone has got the perfect talk that I should bring in. And so fortunately Micah agreed to come in and do the presentation for us. And so I decided might as well open it up to Pone School and whoever else is available. I think it's kind of a waste whenever, we stream the class every night. It's a waste not to share it with everyone. So I will get ready to share the screen over with him, and so he can, let me look at your in here. Thanks for everyone for joining tonight. And let's see. That should be shared with you. Make sure that's working. No, it's one of the computers. So if you can just let me go back and mute all. Okay, good. There
we go. Okay. Hopefully you can see my first slide.
Hold on just 1 second. Make sure you got.
Cool. Hi guys, can y'all hear me okay? Oh, is it echoing? Oh, mic on. Cool. Hopefully I sound okay. Excellent. Cool. Are we ready to begin? When we shut this, or you got it? Or all right. Oh yeah. My slides are kind of tactical. Basically, that just means they're kind of dark, so it helps to have a darker room. Cool. Alrighty. Well, thank y'all everyone for letting me talk. Just to kind of start off, I've only done this just a handful of times, so I am slightly nervous. So if I start sweating or crying or whatever, that's to be expected. So no worries there. I am here to talk about cracking hashes. I don't know what your familiarity are with it is, but I'll be glad to share what I know and how we use it in the enterprise world. So a lot of times you hear hackers doing it or you see it on movies. It's actually a skill that you can use in the enterprise. So with that, I guess we can start off with about me. I go by Micah the Pirate. I'm not a real pirate, so you don't have to hide your silverware or anything. I just happen to like pirates from a, I guess a young age. I just like how pirates think, outside the box, not following the rules, that kind of stuff. The one thing that I will say though, let me see if I can get to the next one is, yeah, I like the idea of thinking like a pirate. Oh, is it locked? Oh. Hey, come on in. Oh, that's okay. So, I definitely like how pirates think it's outside the box and that sort of thing. And going through this, you'll actually kind of see how there are situations where you can think outside the box. And a lot of the things we do in general, if you're in this industry or career field, you probably have that mindset already of wanting to get your hands on a lot of different technologies and do a lot of different things. And so I definitely like pirate stuff, minus the dying and the diseases and stuff. And I like caffeine. So if I, start getting a twitchy eye or something, that's the caffeine that's doing that. So I don't know if there's really that much more interesting stuff about me. So, oh yeah, another point is I am definitely here for you. I have tons of slides, but we can totally get rid of slides. If y'all have any questions, feel free to ask, interrupt. I really don't mind being interrupted or even going on rabbit trails. I am really good at going on rabbit trails and getting distracted, so I'm totally fine with that. And I know it's the end of the day, so if you're tired and you want to take a nap, that's totally cool too. I really enjoy this type of stuff, so we'll crack on with this. I am in InfoSec. I've done it for 3 years, and I think that's really all the interesting stuff about me. So moving right along to the next slide. Cool. Okay, so this is a hash. I'm not sure how familiar anyone is with hashes, but generally anything that you think of a password, whenever you type a password, whether it's creating an iTunes backup, a zip file that you want to lock, an Excel spreadsheet, anything that takes a password, best practice is you want to hash that password into a format like this. Up here I have NTLM and net NTLM v2. Those are hashes that you would see in a enterprise environment. That's basically your Windows hash. 32 characters and 175 characters. What's kind of interesting about hashes versus encryption is made to take something that you know, make it super secret so no one can see it, but also have the ability to come right back to something you know. Hashing was not designed that way at all. It was designed for a one-way street. So that's why reversing the process takes a lot of power. So getting into that, I just wanted to at least bring that as an overview on why there's so much effort involved. Is because it was never designed to go back to and reveal the secret. So the process of cracking a hash is basically converting guesses, whether it's words or characters, it's converting those guesses into a hash really, 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 really fast. So it's making all of your English words or your plain text words and converting that into a hash format and then seeing if the hash matches. So I'll give you an example. But some of the tools we use is Hascat, John the Ripper. I favor Hascat because there are so many knobs and buttons that you can mess with. But John the Ripper is really cool too. It's been out for a very long time. I actually run John the Ripper on my cell phone. So it's very versatile and it's been around for a long time. And then Reaver and AirCrack are some wireless-based cracking tools that you've probably heard of as well. I'll be highlighting on Hascat mostly. So let's pretend we found this hash. This whole talk is going to be under the premise that you have already attained the hash. You can obtain a hash in so many different ways, whether it's using responder and listening on the network, whether it's scrubbing pastebin, whether it's extracting it from an iTunes backup. There's Python scripts to do that, or from a zip file. There's plenty of ways to grab the hash, but this is under the premise that you have the hash already. So here's an example hash that we would like to crack. And so going over the process of cracking, let's take an example of the word soccer ball. Let's guess soccer ball. So the way Hascat does is it takes the word soccer ball, hashes that value, and checks to see if it matches. And as you can see, that does not match. So let's try another guess. Football. So the computer at a really fast rate takes the word football, hashes it out. Does it match? No. Let's try basketball. Does that match? It does not match. Password 1. Does that hash value match this? It does not. Admin 123. Okay, we have a match. And so now we know that that hash equals admin123, and that is our password. That is a very slow step-by-step process of how cracking hashes or recovering hashes works. And hopefully that makes a little sense. Are there any questions so far? There are a lot of different ways that you can come up with guesses. So the question was, does the program come with a lot of words for this to start guessing? And that answer is, with Hascat at least, there are a lot of ways that you can come up with candidates to guess, whether it's brute force or word list or anything like that. And I'll definitely get into that pretty soon. Was there any other questions, or does that make sense so far? Good? Yeah. RSA is a type of encryption, so there is a hash for that. There's 512 and a lot of different SHAs. I can actually show you an example of all the different types of hash types. Hashcat, I believe, supports over 200 different hash types. From all sorts of things, anywhere from cracking an iTunes backup to Android PIN number. So basically, if you can find the hash for it, then you can most likely crack against it. So sure. Oh, there are different advantages depending on what your scope is. Like I said, I put John the Ripper on my cell phone. That's kind of cool to have. Just if you happen to have it handy, you can run through a few hashes that way. A lot of it comes down to preference. John the Ripper is super easy. You literally type in John and your hash and then enter, and it does the magic for you. Hashcat has a lot of customization. So depending on how deep you want to get, there are some that do different things better than others. So it really just depends on what your scope of work is or what you're trying to accomplish. So I generally like Hashcat just because there are so many features that you can work with it. It's just, again, it kind of depends on the scenario. We've used a program called Loft, and it's a very nice enterprise program that comes with support, and you can pick up the phone and get support if you needed help with. And so from a password auditing perspective, that's a really nice tool. Hashcat's very lightweight, and it comes on all Kali builds, the same as John. So Hashcat's kind of one of the things, it's like Photoshop to marketing. You don't necessarily have to be an expert at it, but if you know Photoshop, that's going to help you get into a marketing job. But they don't just use Photoshop in marketing, and so Hashcat's kind of the same. It's a very nice default program to learn, but there are a lot of others to use as well. So that makes sense. I can move on to the next slide of cracking passwords. So now we've covered the process of cracking, which is converting words or guesses into hashes really, really fast. And I'm going to highlight on this mostly in the Hashcat scenarios. So let's look at how that actually works. So when we're converting words or guesses into hashes really fast, there's two ways we can do it to process all of this. Using a CPU, which those are super smart and very fast. And the other type of processor that we have is a GPU. AMD and NVIDIA recently opened up their APIs to where we're able to harness the GPU processor, graphics processing unit, as well. However, those are very dumb processors and they're very, very slow, but it is a method of using computation power to process a bunch of hashes really fast. So our two options are CPU and GPU, and I'm not talking about cloud and any of the things like that. We're just looking at bare metal right now. So between the two, I've got a picture of the Threadripper. AMD Threadripper 2990. That's got 32 cores, and I believe AMD's coming out with a new Epic Rome processor that's going to have 64 cores soon. And this is just a desktop processor that you can buy at, Amazon or Best Buy. We're not talking about servers or anything right now. This is just a desktop processor. So 32 cores, that's a ton. My computer has 6 or maybe 8 cores. So to have that on your machine, that's pretty awesome. So that gets a kind of a cool flame effect because it's 32 cores. The next option is a graphics processor, which is the RTX 2080 Ti. And that actually has 4,386 cores, or CUDA cores. But again, it's very, very slow and very, very dumb. But because it has so many cores in this GPU, you can actually leverage tons more work for this GPU across thousands of cores. The price differences between the two, the AMD Threadripper is around $1,700, and this TI 2080 or RTX 2080 runs around $800. So it's actually cheaper. But when you're going through a lot of this, it's good to have a balance of processor and GPU. GPU is awesome for heavy lifting, but you still need a good processor for doing other functions like creating word lists or crunching numbers or something like that. So it's good to have a balance, but just to kind of highlight why you hear a lot about GPUs being used is because the massive amounts of cores in the hardware. So kind of cool. Mm-hmm. Yeah, it's able to load up work, and since all you're doing is really just some very fundamental hashing, it's not having to, uh, right, you're able to do it across, right, so you're waiting for a new thread to be released to add more work to, and here there's a lot more cores to work with. So, and that's why I said CPU. It's good to have a balance because there's some things that a GPU would be really bad at, and so you still need a CPU to do some of the smarter stuff. So, how can 32 cores be faster? Well, it depends on the type of work you're doing. This just applies for hashing. The GPU will be faster, but um, for things that involve a lot more than just hashing, the CPU would be better, like running scripts and uh, different things like that. So. Right, yeah, but the work that these cores are able to do can't do anything smart. So they're extremely bottlenecked when it comes to doing anything beyond these cores are not the same type of cores. They're actually very different. The 4000 is called a CUDA core, and it's really designed to do one thing. Especially when it comes to like crypto mining, they have certain types of processors like the Ant miner. It literally is, I forget the acronym, but it's literally designed to just do one function and one function only. It can't handle an operating system. It can't do anything extravagant. It literally can only hash, and that is it. And that's kind of similar to this, is that you can't use it for running an OS or doing anything extensive. So, all right. So it gets bigger flames. Sorry, I should have had the flames out there earlier, but more impressive flames. So, oh, and this is a random meme time. Because of technology, we have new shapes. There's the pentagon, the hexagon, the octagon, and the My Money Gone. That's the i9 processor. I wish I could have one, but a little bit too much. But I just thought I'd have a little shapes lesson for you guys. So, all right. Back to cracking hashes. So brute force, we hear a lot about brute forcing passwords and stuff, especially in movies. So let's take an 8-character password as an example. On a standard brute force mode, you'll get about 5.5 trillion candidates. And it's not really hard to get 15 billion guesses a second. You can get a 1080 at Best Buy for like $400, and that'll give you about 15 billion guesses a second. And with that, you can crack an 8-character password in about 5 minutes. So if you have a password that's 8 characters long, chances are you'll be able to crack it in about 8 minutes just with brute force. Brute force is just randomly guessing all characters. It's kind of like throwing spaghetti against the wall and just seeing what sticks. Do what? Right, yes. So being able to figure out what that hash means, you can generally spend just about 5 minutes of cracking, and you'll get that on most common passwords. So let's move to an 11-character password. Let's see what the difference will be with an 11-character password. So with 11 characters at a standard brute force command string, that's 381 quadrillion candidates. That's 15 zeros behind the 381. So a lot more candidates, or a lot more potential guesses. And at the same speed, more or less, that will take you anywhere from 275 days up to 5 years, 4 days, and 10 seconds. And it will definitely make you wait those 10 seconds. It does not give you any mercy. You will have to sit there for those last 10 seconds. So that's a really long time for 11 characters. And I know a lot of passwords probably are 11 characters long. So I know the next question you're thinking is, how in the world am I supposed to crack these hashes before my target ends up finding a different job or working somewhere else, and my target is completely not even working in this environment? Oh, do we have a question? I have a new, let me see if I can go back. The key space. Okay, so trying to figure out the zoom button. Do I got to point it here? Oh, I do. So here is the guess mask, if you want to read that. Generally, if you just type in -A minus A 0 for, I'm sorry, 3 for brute force, you'll be able to get the key space and look at the mask. It's basically, I mean, if you want to get into that, -1 equals lowercase digit upper. So where you see the 1 here, it's guessing a lowercase digit and upper, and then a -2 is lower in digit. So all these 2's are lower in digits, and then the -3 is lowercase digit, and then these common characters. So that's basically what the key space that I was referring to was 381 quadrillion candidates. That Zoom thing is pretty awesome. I like it. Did that answer the question? Okay, cool. All right. So, yeah, how are we going to hack this? We don't want to wait around 5 years. I completely understand. So the answer to that is options. We've got lots of cool options beyond just brute force. So I'll step through a lot of these. Masking is a very nice skill to learn. You actually apply that with hybrid attacks and a few others. There's the word list. And so word lists, you're able to guess words instead of individual characters. So that speeds up a lot. And there's even what's called phrase cracking. So we hear that, you know, making a password is bad to do. So create a phrase. Well, there's actually attacks for phrase cracking. And then there's rules. Markov chains, which is based on probability and statistics. Fingerprint attacks. I know you mentioned you like recon, and so you'll really dig fingerprint attacks where you do your recon and apply what you've learned towards the attack. And then base and mod looping. That's where you can get into even more cool stuff. So I'll go over all of that. But for now, we can start with masking. So the cool thing about masking is it's like brute force. You can control what characters you're wanting to guess. So rather than just have it all random, you can actually specify which character types to use and in which order you want them to use. So here's my example. Well, first, yeah, here's how you would do it. The question mark U equals uppercase, the L is lowercase, D is digit, S is special character, I think H is for hexadecimal. You can actually customize and create your own masks if you like, with like the question 1 and all that. But for an example, let's say the password is unicorns1 exclamation mark. To create a mask for that, you would first start out with the question mark U, and then all lowercase, and then digit and special character. So now every single guess that you're making in this brute force type attack, it will ensure that all of your guesses will always start with an uppercase U, and then have lowercase, and then a digit and a special character at the end. So now you can kind of control what type of brute force attack you're doing. Right. And that's one of the things that I'll even cover on why you would. But the short answer is, if you kind of think about your own password or think about passwords you've seen in the wild, chances are it's a password. So let's start it out looking like a word, maybe with an uppercase character and all lowercase, rather than just randomly all sorts of different characters. If you know your target, like you're saying, reconning, then chances are maybe they use a word at the beginning and ending with something fancy at the end, like a date or a... Right. Yeah. You can choose if you want to make a custom mask. So in the command line, you would do a -1, and then you would say lower and upper, and then you just put a 1 at the beginning, and it will do all lower and uppercase at the front. The more specific you can get, the more time you'll save. But again, you might miss it too, and you have to start all the way over and broadening your attack mask. So, but you'll come to find out that just masking alone is definitely not the best tactic. It is a good one for certain cases, but there are other options that we have, so such as a word list. Word lists are a nice way to be able to guess the entire word at a time. So rather than guessing different characters at a time, you're able to guess chunks of characters at a time using a word. And so that can speed up quite a bit. And passwords get dumped all the time. I have a side project that dumps passwords in the wild every 5 minutes. And it is just phenomenal how many passwords are out in the wild. So a word list is definitely a really good option to use. And you can add masking at the end of it, called a hybrid attack. So that way you're using your word plus numbers at the end, because you can't figure out everyone's anniversary dates or something. So just put a bunch of digits at the end, and you'll be able to do a hybrid attack, which combines words and masking at the end or at the front. And then rules. This is a very cool feature to use. A lot of times, you've probably seen passwords where they substitute the E with a 3 or the A with an @ symbol. It's called leet speak. You can apply a rule that says, for the example, if the password is pirate, anytime you see a I, you can tell the rule to say, go ahead and guess pirate, but also guess an exclamation mark anytime you have an I, and then basically fill out the leet speak rule. So it kind of attacks the leet speakers who create passwords based on that type of password generation. The other example would be password policies. So if your organization says all passwords need to be 12 characters or greater, well, you wouldn't want to spend time cracking and guessing passwords that are only 8 characters, because that doesn't fit the policy. So you can create a rule that ensures that every guess you make is inside the password policy, with complexity, length, all of that. And then also your objectives. So say you dump the entire database of a domain controller, the DIT file, that may have 100,000 hashes in there, but really all you need is maybe 10,000 of those hashes. So you may use one rule just to get just to prove a point. Other cases, you may just have one hash that you absolutely have to crack. Well, you would use a different rule for those instances. So depending on what your objective is, if you have to get get as many as you possibly can as quick as you can, you'd use one rule, and for a very specific target, you would use a different rule. But there's all sorts of different ones. So are there any questions so far on any of this? Nope. Okay. Markov chaining, that's kind of a cool concept. It's built into Hascat, but it's basically, for example, let's say brute force tries to guess the letter Q. Based on statistics, what letter follows after Q most of the time? It's U. So rather than guessing an X after it or a T, anytime we guess a Q, let's go ahead and put a U right after. And that's kind of the core concept of Markov chaining, is it looks at what's in front and behind, and it basically makes a guess based on statistics of what should be guessed. And you can do a lot with word lists and different things like that. So Markov chaining is a cool concept. And then base looping and mod looping is another option. In this case, the Prince attack, if you want to just set it and forget it, you can use the Prince attack method to infinitely guess forever, but it'll do it based off of the word lists that you have, such as what's called the purple rain attack, that will take the dictionaries that you have and guess based on probability and statistics. And if you just kind of want a set it and forget it type of attack, the Prince attacks like purple rain is a good attack, to where it'll just run forever and ever. It may not necessarily get it all, but if you have a lot of time, that's one way of using that attack. Let's see. Okay, the masking example. So here's going back to that 11-character password that was going to take 5 years to crack. This is where you kind of think like a pirate, or think outside the box, or think, almost like what would you do yourself. So on this 11-character password that we want to crack, maybe it starts with an uppercase. A lot of passwords that you've probably seen start with an uppercase letter. Maybe it's a word. I mean, password, most people use words for passwords. It kind of makes sense. And then maybe it ends with something fancy. I know I kind of touched on that, but for that 11-character password, let's try this mask. The A's at the end means try everything. We don't know what the fancy stuff is at the end, so I'm just going to try a word with fancy stuff, and let's see what happens. By using the mask, it actually brings us down to 129 days from 5 years. So using a mask, you can see, cuts down the time dramatically, but that's still kind of lame, because I don't think anybody wants to wait 129 days to reveal the password. So on to word lists and rules. This is where I kind of enjoy cracking passwords. The dive rule is one that you would want to use if you really, really, really need to crack this hash. It's one that will take a very long time to crack, but it's got some pretty neat things about it. It's got 99,000 rules in there. So, and it's sorted by success. So it's always going to hit after the most successful rule and work its way down. And it's been known for cracking over 70 million passwords. So there's our rule that we're going to use for this 5-year-long cracking password. And if we add a word list to it, I'll use the dark code word list. That dark code word list is 1.7 million words, but combining that with the rule, we now have 145 million candidates. So actually, I believe that's billion candidates. So rather than just a small word list of just 1.4 million, that's actually 145 billion candidates. So you have a lot more guesses that you can use. And by doing that, we crack this hash, this 5-year hash, in 39 seconds. So you can see that using word list and rule will really speed up time, because the word list, you're guessing chunks of characters rather than a character at a time. And the rules, it goes by commonality, highest success rate. And this was on a laptop. So 39 seconds, I think I actually had it done in 3 seconds on a desktop. So not too bad. 39 seconds cracked. And Richland 19 bang is the password. So that's the 11-character password. Kind of cool. Before I go on, were there any questions so far on? Yes. Mm-hmm. Yeah, I wish. So the answer is, say the password is Apple, and some other stuff, but say your word list has Apple. Do you get partial credit for guessing part of the credential? And that is, unfortunately, no. Every character that you add to a password completely changes the hash value. And hashing in general, you can hash a file. And what's interesting is, say you have a text file like on your desktop or something, and you have some stuff inside there. If you open that file and just put a space in there and close and save it, that hash for that file changes completely. You can rename the file and the hash stays the same, give it a different name. But if you change anything inside that file, the entire signature is different. It's not like the character at the end changes or anything like that. I haven't planned on doing that, but I can, um, touch on that, I guess. I was also going to do a demo too to show you kind of what hash cracking is like. And I know you're not supposed to trust a pirate, but I brought USB sticks if y'all want to have the tools that I use. But I totally get it if y'all don't want to. And there's a way to join Meetup and Slack if you want those tools. I can offer that up as well. And I've got a lab and a cheat sheet that you can print out and all this cool stuff. If you're interested, I'd love to share that. So, but yes, no partial credit for guessing part of the hash. One interesting type of hash called the LM hash, there's a limitation. It's kind of old, but it will actually break the hash in half and guess half and half. And so that's the closest you'll get to getting partial credit. So, okay, so advanced attacks. This is kind of a new section of like probably things you may not have heard of. But it's usually just kind of special situations that you would use these types of attacks. So the word list. Where do you get word lists? Word lists can actually be found all over the place, such as the Adobe breach. There's word lists from words out of the Bible, out of cities, Facebook. There was some breaches from Hotmail, LinkedIn, Muslim Match, MySpace. So a lot of those breaches, there's already word lists for those. There's default cred lists. There's even do-it-yourself. There's a cool tool called Cool that will actually scrape the front end websites and create a word list for you. So if you're doing some recon, chances are maybe the company uses passwords that have their company name in it. You can do it yourself. And then there's Wheel, bring your own word list. I don't know how to pronounce that, but I made that up actually. But you can start adding and collecting your own, doing your own stats on it. There's some tools to run stats and dedupe and combine it, but you can always use your own word list. So word lists are found everywhere. Language packs is another interesting one that, depending on if you're pen testing for a different country, there's even language packs for words that you don't know. If you're not multilingual, you can get one of those packs and get a bunch of common languages and crack that way. And then there's keyboard combinations. So if someone likes to make patterns on their keyboard, there's some tools to actually create those patterns for you. And some lists are already made. So a lot of different ways to get word lists. And in the lab that I have, there's even links on where to find some of those word lists. There is a 2 billion probable word list, and I'll highlight that because that's a very cool concept that you can get. But probability word list is something worth Googling and getting in your toolkit. And then there is even an 8 billion word list from WeakPass that is a 90 gig file, and it's got 8 billion words in there, and that is definitely a huge file. But those are some word lists that I've come across that have helped me in different situations. So going back to that probability, let's take, for example, in those word lists, this is why probability matters. The password dragon in the probability list shows up on line 11. You probably are familiar with the ROCU text, but that's a very popular word list. It shows up on line 85. And that's a pretty big significant difference. That means you're having to work your way all the way down to line 85 when you should be looking at a word from a probability perspective at line 11. And then the exact opposite is true for the password computer. The probability list is lower. It's line 20. And the ROCU text is actually upping it to line 83. So it's kind of conflicting. ROCU is actually promoting a less probable word. And I know that probably sounds confusing, but probability definitely matters. Out of the two lists that I ran from a probability perspective, I cracked one hash in 30 seconds, and the ROCU text took 6 minutes. So there's a pretty big difference, and so it's nice to hit the words from a probability perspective. So just wanted to point that out. Are there any questions on that? Make sense? Okay. And let's go to the next one, table attack. So like the language packs, where it's full words of different languages from whichever region, there's what's called the table attack, where you can create a letter and put it in a table, like a lookup table. And so even if you're using an English word, but say I substitute the A in pirate with one of these international characters, you can actually say, go ahead and guess the A in pirate, but also look across this lookup table to fill in all of these. So if anyone is using a different type of keyboard or using some of those alternate keys, you can create a table attack and it will actually go after any of those other foreign characters. So it's not the same as same type of attack as just getting a language pack where the entire word is different. This will get those underliers where it's an English word but with some different font or different text included. So. And then the hybrid, that is the type of attack where you can add custom stuff at the front of a word or the back of a word. So that's kind of cool. Yeah, and then the word list plus fancy stuff. So for example, princess is a very, very highly common password for whatever reason. And chances are maybe there's someone's anniversary date or something. So an example of a hybrid attack would be using a word list plus that mask, digits, probably a year or something, and then a special character at the end. So that's how you would use a hybrid attack. You can put it in the front if you want or in the back. That's how hybrid attacks work. And then the fingerprint attack. This is kind of a cool concept, but it's basically as you crack passwords and you start seeing all of these passwords in your pot file, anything that you crack shows up in a Hascat pot file. So that way you don't have to crack it a second time. If you already got it, it'll first check to see, have I already cracked this before? And if so, it'll skip it. But you have a file that holds everything you've cracked. So why not add those new words that you've cracked into your word list? And now, if a company uses the word, Richland, for example, maybe someone uses Richland with some other variations. Well, since you cracked Richland, let's add that to the word list, and now your rule will apply to that. And then once you crack something else, add that to your word list. And so you're basically fingerprinting what you're doing. And there's ways to automate that, but at a super high level, that's kind of an awesome way to utilize the fingerprint attack. Are there any questions so far online or anything? 20 character. Okay, so the 20 character password randomly generated, is that what it was, like from a vault? Password manager. I'm under the mindset that anything is possible. Generally, password managers use a very long encryption or a hash algorithm, so it takes a lot longer per guess. So there are ways, which is probably my next point, called a distributed attack, where you actually have multiple agents attacking different things, and so that's where you would leverage that. I will say 20 characters is hard to crack, but it's definitely not possible. I've cracked 20 characters before, so and if I can do it, anybody can. Just kidding. But yeah, it's doable. So and then the fingerprint attack, in the basic example that I gave was, as you're cracking passwords and you now have all of your answers to those hashes, why not take those passwords that you found and put them into your word list and crack against that new word that you have, and basically build your word list, make your word list kind of a living, breathing thing, to where as you're guessing the ones that you haven't recovered yet, you've got more ideas to put into your word list. Because I will say a lot of the word lists out there don't comply to enterprise level complexity. Some of the passwords are literally 6 characters, and most organizations don't have a 6-character password. So it's nice to come up with more enterprise type passwords, and then also those that are more custom towards your target. So yeah, does that make sense? To be honest, I haven't dabbled anything into cracking salted passwords. I feel like the way that works is you have to first crack the salt, which is a hash in and of itself, and then and then once you have that, you can crack using that hash, or that recovered hash, to then crack the other. So it's a hashed hash, if I believe I understand that correctly. But to be honest, I haven't messed with salts that much. I haven't cracked a salt or come across one. That's something that I do need to learn. But that's just really all that I know about that. I'm sure someone probably knows a lot more about that than me. So I'll have to look into that and get back with you on salting. How do I automate? Is that Sheldon? Oh, I'm just kidding. Oh, oh, okay. Nice. Well, so there are a couple ways that you can automate this. There's a really interesting tool called HateCrack, put out by TrustedSec, and they have a script that you can run that will actually automate a lot of these types of attacks. It even has a word list optimizer, so you can throw tons of word lists together, and it'll actually optimize all of your word lists into one ginormous one, and that will allow you to automate a lot of those types of attacks. It will utilize a fingerprint attack, which is pretty cool. And then the other tool that I use, which is actually the next bullet, is the distributed attack. Using a program I found called Hashtopolis, it's open source, so anyone can download it. You can stand up a server. I think it's just a LAMP stack of Apache and MySQL, and you have basically a mothership that you connect to. It's like a website, and whether you're running Windows or Linux, you can actually go to the website and download an agent, and I could literally have all of y'all go there and download an agent to your computers, and it becomes a distributed cracking system. So if I have a ginormous list or some really tough hashes to crack, I can start sending the work to all of these nodes, and you're basically just running an agent on your computer. And as it finishes its tiny little amount of work, it looks for some more work and brings it back down. But Hashtopolis has a few automated tasks that you can do called super tasks, and you can really get nerdy with that. Probably won't go too deep into that, but definitely check out Hashtopolis. It utilizes what's called Hascat Brain, or the Brain server, and it can handle the distribution of the workload. So another cool thing. So good question. Is there anything else? It's really anything that can install a binary and run a binary. So Linux, anything that can run a Linux binary or Windows binary. It could be virtual if you want. Generally, bare metal seems to work pretty good. I know there's also cloud compute that you can use that will, if you feel like ponying up some money, you can run that way. But I think it's I forget which attack it was, but well, for example, the Bitcoin stuff, you've seen people getting on people's computers and mining from their browser to collect a bunch of Bitcoin. That's a distributed type of hashing, and I sorry, I'm not asking the question online, but yeah, the node is it like I said, it's really whatever you can install that agent on. So it can be bare metal. You could run it on a Pi if you really wanted to. Generally, the better hardware you have it running on, the better the results. But theoretically, yeah, if it can run this script, it basically does a call up. It downloads any word lists that you want to use down to your machine, and starts grabbing any hashes or work that it has for it to start cracking on, and it just basically makes a copy of what your task that you have set up for it to be, whether it's rules that you want or a word list or anything like that. It'll bring it right down, and you can even export your word list and use that word list for other other tasks. So. Okay, so this is really the last part of attacking, the phrase cracking. They say don't use words for your password, use phrases. So here we'll look into phrase cracking. One method is using the combinator attack, and it's basically taking two word lists and putting one word list on the left and one on the right and putting them together and guessing a word. And so that's one method of phrase cracking. It's definitely, I haven't seen too many phrases to crack. A lot of people, or at least a lot of hashes that I've seen, are just words. So I'm really interested, as time goes on and we start moving more towards past phrases, utilizing that. But when I do want to crack phrases, there are a lot of different resources you can get for collecting phrases. So this one tool that I found will actually go and it's collected phrases from all sorts of things, like the Urban Dictionary, titles from the IMDb data set, over 300,000 books, presidential debates, meme tracker, to see what's what's trendy. That could be someone's password is like some meme. And then the top US and UK album names, artists, and track names from the 1950s to 2018. Those were all phrases that you're able to pull into a phrase list, kind of like a word list, but these are all phrases. And so what we will do with that is take an example phrase. So one of the phrases I picked out was a house divided against itself cannot stand. Very famous quote, and it's a very long phrase. And generally, the longer the phrase, the harder the crack. As you notice, the 8 character to the 11 character, this is a massive phrase. With a phrase cracking technique, it takes all of those words and it will actually attempt them in different orders. So if I have that phrase in one of my phrase lists to try to guess, using these attacks, it will crack if your password is a divided stand. So if your password's a divided stand, using that one phrase will crack that. It will also crack stand against a house, because all those words are listed in that phrase. It will just kind of mix them up and mix and match and will crack if that is your passphrase. And even if your password is super long, cannot divide itself against a house stand. It makes no sense. A lot of times you don't want your passphrase to be like over the rainbow or something that's easy to guess. They say mix up your words. Well, this combinator and what I call phrase rules will actually mix and match all of these words in different orders and would even crack a password that long. So to that 20-character question, even phrases, if it's not randomly generated, if it's just literally a phrase, it could crack as long of a password as that. So that really does wrap it up. I don't know if there's any questions at all online or in here over what we covered. I know I brain dumped quite a bit, and I don't know if you've ever been in that scenario where, like for me, there was something I was learning and I knew absolutely nothing about, and it was to the point where I didn't even know what to Google. Like I knew I needed help, but I didn't even know what to Google. So everything I just threw over at you guys. Hopefully, if you're ever in a situation, you'll just at least have a nugget of what to Google. Like, oh, that was called a table attack or purple rain attack or something. And so this, if nothing else, will help you know what to Google, because I've not even known what to Google before. So, but yeah, are there any questions? You can, yeah, the phrase rules will also, if you want to add that leet speak rule into your rule. Right. Yeah. Yeah. You can add that. The rules, there's a lot of really cool rules. In fact, there's one called the one rule to rule them all. And there's a really cool article about when to use which rules. And a lot of people put tons of time and research into building really nice rules. And so chances are, if it's something that you're looking for, there probably is a rule out there for you, but it is something you can also make yourself. So if it doesn't exist, if it's a very special situation, you can definitely make or add to an existing rule. So. And I also added some frequently asked questions, if that will jog anyone's or spark some interest or whatever. Oh yeah, another question. The dive rule, okay. The dive rule actually comes preloaded or comes with Hascat. So when you go and Google Hascat, there's a lot of interesting rules in there. The dive, like I said before, was a rule that you'd want to use kind of like your last ditch effort. It will take a long time to go through, but it will definitely cast a very large net. The quick wins for the rules that come with Hascat would be the Insider Pro Passwords Pro rule, the Best 64 rule, and the trying to think of another one that's really handy. I know those two for sure are really quick wins that will probably crack a mass majority of passwords. Yes, I got to use one. It was kind of, it took a little while to learn, but the way it worked was a north, south, east, west mentality, and you can choose how many times you want it to walk south from your starting point. So say Q is your starting point on the keyboard, how many times you want it to walk south, east, west, and you can actually start picking up a lot of patterns, and it'll generate tons of keyboard walking word lists for you to use. You can do the basically the base looping and mod looping. You can pipe that into Hascat, so you can do it on the fly. You don't necessarily have to generate that ginormous word list and have gigs and gigs sitting on your hard drive. Using the base looping and mod looping, you can pipe that into Hascat and do it on the fly. So it's pretty cool. That answer that? Cool. All righty. Yes. Yes. Here's I don't know if Philip has shared this information, but here's the Slack channel if you're interested in this, or you know, woke up at 4 in the morning and realized you had a question you forgot to ask. You definitely can join. I think there's a lot of different types of people that have joined, some who are professionals, some who are just getting into it, but it's a very fun group, and we even have a channel dedicated to memes, so if you like jokes and stuff, there's plenty, more than you could ever want. We make sure that we only have the best, so but yeah, definitely get connected, go to a meetup. But that's where you would find the Slack channel and the meetup URL. That's really all I have for slides. I can definitely go through a demo and kind of show you what the command would look like if you'd like to see some hashes getting cracked. Let me do that. Yeah, okay, well, cool. Before I fall out of my chair. Okay, so let's see if we can get this going. So I've got this really awesome looking walkthrough. If anyone would like it, it has step 1, step 2, a lot of information on what the files that you download look like, and even a cheat sheet that you can print out. Oh, you're not sharing? Hold on. Let me start over. Let's see here. New share. Let me stop share. Here we go. Actually, let me just share my screen. There we go. Okay. Excellent. All right. So I have this really cool document. Actually, it's not that cool, but I have a document, and it's got a lot of steps for cracking your own hashes if you're interested, and it has some description on what each file means in that folder. But literally, it's just copy and paste into your command prompt if you wanted to run through it. And then at the bottom is a cheat sheet with some really cool URLs, like this one here, the John the Ripper URL, has a lot of Python scripts to extract hashes out of Office documents and zip files and things like that. So a lot of cool resources there. And then this seclist URL has lots of really cool stuff to include word lists. And then the base loop and mod looping URL if you're curious on how to leverage that. But let's see if we can get started with cracking a hash. So when you download Hascat, and so I'm running this on Windows, and according to Hascat's documentation, which OS is better, Hascat actually says they are basically the same. You can run on Windows or Linux. I've actually had lots of issues with the default Kali for some reason. I don't know if it's built right, but just a lot of graphics display drivers issues that I've had with that. Windows just seems to always work, in my experience at least. So, but like I said, according to Hashcat's website, they specifically say that Windows, Linux, whichever you're more comfortable with, go ahead and use. So I will go ahead and open up command prompt and go to the first step, which is basically copy Hashcat, know where your Hashcat file is. So I'm just going to CD to desktop and Hashcat. And the next step is I'm just going to copy and paste this URL, and I can explain what this means. So I'm basically running the Hashcat binary. -A is the attack mode, and 3 is brute force. And then -M and 0 is basically saying this is an MD5 hash. Here's my hash. You can also put loads of hashes into a word list or into a file. So if you have like 50 hashes, you just specify your text file here. In this case, I'm just going to put my hash there. But if you wanted to have like a hashes.txt file, you can definitely do that. And then the -- session equals test. I'm basically creating a session because if it does take 5 years, I might want to use my computer one day in that 5-year time frame. So I may want to like pause or cancel or, come back. So by creating a session, it will save exactly the point that you left off at, and that way you're not having to start back from ground zero. So that's kind of cool. So I'll hit enter. It's going to start, and it's going to start cracking hashes. And this is what it looks like on my little laptop. Yes. It probably would, just because each hash would be different. And so, but it does definitely try to use the guess and match across all 5. So having more hashes doesn't necessarily slow down it from a work perspective, but just finding out the hash value will take longer. So we cracked that first hash test. Super easy. That took 0 seconds according to this. And you can see the guess mask was a 4, so it was 4 characters. It stopped there. But looking up here, you can see that it tried 3 characters for a while and began with 2 characters. It exhausted 2 characters. Anytime you see exhausted, it means it ran out of things to try. And so we cracked that one. The answer is this. It basically prints out an example of the hash here with a colon and then test. The password was test. So when you run that in here, you create what's called a Hascat pot file. So you can always open this up, and anything you crack will show up in here. So that way, if you find this hash again, it won't try to crack it again. It'll first look here, and if you already have it, it'll skip it and say, hey, you already have this. I'm not going to work twice. So that's kind of cool. So let's go to something a little bit more difficult. And this is the 11 character password. And just to show you how long that 11 character password would be. See if we can get it to work. No? Whoa. I am pushing all kinds of buttons. Copy. Let's try this again. There we go. Okay. So kind of the same thing. I'm starting with hashcat.exe or bin if it's Linux, -A3, and that signifies a brute force. -M0 signifies that the hash that we're going to crack is the MD5, and so here's our hash again. And then the -I incremental, min equals 11. That just basically means let's start with 11 characters. So for example, if your password policy is 8 characters or greater, you could say start with 8 characters. When you saw this previous one, you saw how it started from 1 to 2 to 3. You don't need to waste that time, so you can start with 11. So let's start this up, and I'm definitely going to be canceling this because it will probably take a while. So it's running so hard that it's basically just has a status bar right here. So I can do things like P for pause, and so it's paused, and then R for resume, pick back up, Q for quit, and then if you want to see where it's at, you hit S for status, and wow, 6 years, 223 days. I should probably not wait this out. So I hear my... Right. Yeah, I don't think anybody will stick around for 6 years. I think, so I'm going to go ahead and hit Q for quit. And, well, let's find out. That's going to be the next, I'm really excited that you asked. So now we're going to use this dark code rules dive and then session YARG because we're all pirates, right? Or at least I wish I were. So we are going to now change it up a little bit. So now we're running hashcat.exe minus a 0 instead of a 3, and 0 means we're going to use a word list this time. Minus M0 is the same. We're going to use an MD5 hash. And since we said a minus 0 because we want to use a word list this time, we specify our word list, which is the dartcode.text. And we're going to add a rule. So we do a minus R for a rule. And then in Hascat, there's actually a folder called rules. And right inside here, when you download the Hascat zip file, here's a bunch of rules, and there's all sorts of different rules. And so here's the dive rule that I know someone was asking about. Dead 1 rule, best 64, the insider pro passwords, those are all really good rules. The ones that take the longest to run is the dive and the RockU 3000. Those are just the biggest that as far as what comes with Hascat. But here's where they're all found if you would like to run it against a rule. So we're going to do that against the dive rule, and I will hit enter. And let's see what that 6-year-long password ends up being. I'm going to hit status. And so instead of 6 years, it says it'll be a maximum of 6 minutes. So we'll let it kind of bake a little bit. In here, there's some interesting things that you'll want to look at, like the utilization, 91. If your utilization is really low, like in the 30%, it means you're actually not giving your computer enough work. It could actually handle more. So the way to give it more work is by adding more rules, giving it more words in a word list, but just giving it a lot more work. And that's how you know that your utilization is high. Here you can see we're at 2.89% of all possible guesses. I'll hit status again to see if we're any further. Now we're at 10%. And here's the hash rate. Right now I'm guessing at 314 million guesses per second on my laptop. And it shows that I'm using the dive rule and the dark code word list. I don't think it will take 6 minutes. Well, I do know, and people more familiar with the IT realm, I believe like that's kind of why you would cool data centers and stuff, is generally when your hardware is at a cooler temperature, electrons seem to flow better or happy. So in here there is what's called a watchdog that you can set, and generally 90 degrees Celsius is what it's set by default, but you can change that up if you'd like. And you can see I'm running at 64 degrees Celsius. Here it's at 71 degrees Celsius. You may want to check with the manufacturer on what the hottest temperature can be. True. Yes, you can control the fans. Sometimes it just depends on if you have the drivers that support it. There was some times where I noticed a driver was old and goofed up, and it couldn't even read the temperature. So that could be kind of scary. And then the candidate part right here shows you what it's actually trying to guess at that moment in time. Was there another question? Oh. Yeah. I hope this is the right hash. I may have given myself a really hard hash. I hate when I do that. While it's running through that, let's see, this is the dive rule on dark code. Okay, yeah, that's what I was going to show you. So you can see how long this takes using the dark code text list. I'm going to go ahead and quit this, but this will crack it in a few minutes. But I'm going to go ahead and quit before it does, because I'm going to specify that probability word list. let's see how fast it takes to crack that. Top our rules, and then what did I do? Dive. I can't see my screen. Why is it not? Is it that way? Rules, dive, rule. And we won't worry about the session. Okay, so we're going to run this. And rather it taking minutes using a probability word list, still 6 minutes, but boom, I cracked it in 5 seconds. So it's Richland 18 exclamation mark is that credential. So there you can kind of see that a word list does matter. I used the dark code. It was going to take 6 minutes, but if you look at that at an exponential rate with hundreds of hashes, it really does benefit you to use a word list with probability in mind. So pretty neat stuff. One thing that you can also do is if you wanted to try this out yourself and even try to crack your own password, there's MD5 generators, there's NTLM generators, and you literally just put in a string and it will generate the hash for you so you can try to crack against your own password or crack against a password just to kind of get a feel for how this works and how difficult different hashes are. Some, here it shows that I was cracking at almost 400 million guesses a second. That's pretty fast. But hashes that come from like LastPass or, 512, SHA-512 hash, you're guessing at maybe a few hundred a second on the same hardware, a few hundred per second versus millions a second or billions a second on some of the easier hashes. So the hash type does make all the difference. And so the distributed type cracking systems are really nice to have for those really long and hard to crack hashes because you can separate the workload. So yeah. Any other questions? No? Okay. I'm a what they call a purple teamer. So I wish we could have a red team, dedicated red team, but one thing that is kind of interesting is no matter where you work or even just at home, you have a blue team of some kind, whether it's Windows Defender or something. You have something defending you. And so there's always going to be that blue team. And so it's nice to learn the blue team side. And just getting in that realm, it's also nice to learn the red team side as well. So I do both blue team and red team, but from day to day, I would say it's a pretty good balance. Yeah, there's a really interesting tool that I use called DPAT, Domain Password Automation Tool, or auditing tool. And it's a few Python scripts, but what it'll do is it'll actually dump with a small one-liner, you can dump the domain controls hashes and allow you to crack them. Those results will then do statistics on them, such as password reuse. How many times is one password being reused in your organization? Because if that one gets cracked, they'll domain spray that and find where else they can get in. So we use that to find password reuse, character length, and it's really spread some insight on challenging our password policy. Because if your policy is lame, you can't get onto anybody by making a lame password. If your policy is that way, they're basically just following the rules. So it's helped us in that regard. It's DPAT is the initial, but it's Domain Password Audit Tool. And it was put out by a lady named Carrie Roberts from Black Hills. Yeah, she definitely is what got me interested in this, and just have really gone bananas with it ever since. So, and then LoftCrack is another enterprise tool that it runs on Windows, and it's very easy. So if you're trying to operationalize something with little to no knowledge, it's kind of the start button push, and it has a lot of really cool smarts inside it. There's not a lot of customization, so if you like that, or even reporting, there's little to no reporting, but it will definitely shed some light, and that's a good tool. Yeah, it is. They still sell it. Loft version 7. They're celebrating their 20th anniversary, so surprising, but yeah, you can still buy it and put in support tickets, and yeah, 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 right. Yeah, yeah. Yeah, and in terms of like hardware limits, 27.5 characters is the maximum length that hardware that we have today will crack. So if you're looking for the uncrackable, even if you put that 27.5, really 28 character in a word list, and that your password is sitting in someone's word list and they try to crack against it, hardware wouldn't be able to crack it. So if you're looking for that magic number, 28 characters or greater is that for NTLM. So it's kind of interesting. It has to do with the bit count in what Hascat is able to support. I forget. I have to read it again. Um, but whenever it breaks it out into bits, it's too long. I forget. I think that it's actually like 55 bytes long, that it won't support anything greater than that. There's actually, yeah, possibly. I don't exactly remember why, but yeah, I, I'll have to find that article that I was reading on, because I was curious. There's actually a list of hashes and the maximum way, the hardware limit for each hash type, and so you can actually look that up and see which hashes meet that unbreakable length, because it's different for each hash type. I think for SHA 256, it's like 18 characters or something surprising. So it's not used too often, surprisingly, but I think because of how much hardware has progressed, especially in the GPU era, once AMD and NVIDIA released their API to leverage GPUs, it's actually faster to just leverage word lists instead of rainbow tables. So it is considered antiquated, but I think it is still a mode if you want to. But yeah, that's nice. Oh, that makes sense. Yeah, that makes sense. GPUs are faster than disk I/O. Okay. Yeah. Yeah. I want to say, so whenever I'm looking at really large pot files that have basically, whenever you run Hashcat, it first checks to see if you've already cracked it. I've ran across a pot file that is about half of a gig, so not too crazy, but I have word lists that are much bigger than half a gig, and using the CPU to look through that pot file actually took surprisingly a long time before it even began the cracking process. Um, that is something that's definitely worth looking into. But I do know that when it even just tries to look up the pot file that it's stored, that's surprisingly a long time if they get pretty big. Um, and that's kind of going back to having a good balance of a CPU and a GPU. So, that's right, for today only. 28 is definitely a good rock solid length. And yeah, that is one of the things. The legacy systems sometimes don't support something that long, but standard Windows. Well, okay, so most of this talk was really one major point of all of this was to prove that password should not be your only line of defense. If you're relying on a password to be your defense, you can see how easy it is to guess and crack. So what we usually recommend is multi-factor, two-factor everything, because at that point you don't have to worry if someone has your password. I could literally tell you my password, but without having my phone with me, if you don't have my phone to get that code, then having my password is essentially useless. But if password is the only thing that you need to get in, then you're basically just putting a key in the door and leaving the key in the door, without having that second factor. Device trust is another thing that we're looking into as well, which is interesting because I can trust a device more than I can trust a password. Anybody can have my password, but not anybody can have my phone. And so that's another method of multi-factor. I believe Windows is even looking into passwordless logins. And I think it's native into Windows 10, where you don't even use passwords, and they're using the device trust technique because you can trust a device a little bit more than you can a password. Yeah, if it's 4-digit, and there's actually techniques to bypass multi-factor as well. There was an incident where what happened was it was a phishing link that was something that was really exciting and awesome, and they clicked on it, and it said to log in. And so they logged in, and then it prompted for two-factor, but the two-factor was actually a phishing site. So the person had their code, put in the two-factor on the fake code on the fake site, and that fake site took the code and actually two-factored them right in and got access to the account. So even the whole code thing can be bypassed, and that eventually you get to the point where it really depends on the person themselves. You can put as much technology as you can in place, but ultimately it takes being aware and really paying attention to what you're doing. So even two-factor can be bypassed as well. Yeah. um, yeah, like SMS or 4 characters. It's definitely generally they're considered one time, and so any guess you make, it kind of nullifies that login. So you kind of have to redo. And a lot of systems now will email the user saying, "Hey, someone's trying to get into your account." So trying to brute force two-factor is kind of noisy and not really used often. So, but yeah, that's all I've got. I don't know if there was any other. I think I can send them out. Um, let's see here. Actually, we talked about how to use this skill for good, auditing your corporate passwords, policies. protecting is multi-factor. Don't recommend saving your passwords in a browser. Use a vault, because there's a lot of malware that will dump your browser history and your stored credentials. So I wouldn't recommend saving your passwords in a browser. Do you need a cracking rig? You do not at all. You just saw me on my laptop crack a password in a few seconds, and I actually did a competition between my password cracking rig and my cell phone. My password cracking rig was doing the default brute force, and my cell phone was using the wordless. And my cell phone, I took eHarmony had a breach, and so I took the top 100 passwords from eHarmony and put them on my cell phone and on a cracking rig. And my cell phone cracked all 100 hashes in a couple of minutes, and my password cracking rig brute forced all of them in about 10 minutes. So it's the whole concept of cracking smarter, not harder. You don't necessarily need a cracking rig to do this stuff. An app for what? For John the Ripper? Yeah, it comes with Kali, and then if you like to dive into the mobile world, for Android, I don't know if you have to be rooted or not, but on OpenWall's website where you download John the Ripper, there's actually something called Hash Droid Suite, and it's just an APK that you download onto your phone and install, and it leverages rules and word lists and everything that you would want. It's little check boxes. You just say, use this rule and use this word list, and nice and handy. It's not for the faint of heart. It's kind of buggy, but kind of cool. And my favorite pirate is Captain Blackbeard. He like melted wax and put it in his hair and set his hair on fire. That's just like really cool. So I don't know if it's because it involves fire and pirates, but William Teach or Captain Blackbeard was my favorite, just for the hair on fire thing. That was pretty sweet. I knew y'all were wondering, so I think it's September something. Talk like a pirate day. Well, what was your question? Yeah, I think he did get hung. Yeah, yeah, right. Yeah, no, I don't want to encourage shenanigans or anything, but or setting your hair on fire. I don't want to encourage that either. But uh, it's cool. The things you could do back then. So that's all I really have. I really appreciate you guys letting me talk and share this. And if you have any questions, let me know. So yes, the easiest way is in this Slack, and then I can give you my email address too if you'd like. I can share that. Do what? See, I need to get into. I don't have Twitter or Facebook or LinkedIn. It's really. I know I need to get into the 2004 era. I just haven't done that yet. But that's otherwise I would give it. But um, it's 400-62191 is my ICQ number. Yeah, 98, I think, something. Yeah. So there's my ICQ number, but I lost my password, ironically. As soon as I find enough courage, I guess, Yeah. Yeah, it would be cool to do a crack smarter, not harder type talk where we get into, some of without knowing the audience of, how deep we want to go, or if we want to start high level. But there's a lot of cool stuff you can do with cracking smarter, not harder. So I actually did a competition a few weeks ago, and kind of going back to the think like a pirate thing, one guy literally just he just stared at his screen. That's it. And he just thought about a password that would potentially be it. He literally hashed that value out and guessed it. It took 0 cracking. And so, just kind of thinking outside the box, look for installation manuals with the password listed in a PDF. There's so many ways where you can get passwords without even cracking, that are even easier than a word list, So thinking outside the box, look for documentation. That's where I find a lot of passwords. And like this one guy, Josh, he literally just stared, thought about it, hashed it out, and guessed it. So just using your noggin, is another way of cracking passwords. So cool. Well, that's all I've got. If there's any other questions. Cool. Micah the